Hey, Eli.
Hi.
How are you, sweetheart?
Good.
Good. Did you get any snow?
No, ma'am, just a lot of frost.
Oh, yeah. That's what we got. Icy stuff. Hey, Reese. Hey, Steven. Good morning. How is everybody?
Hey.
Do you all just want me to work through the review so you can check your answers and see how to do it? Or do you have specific questions?
I want to make sure that I'm doing like the last several ones right about the absolute values.
Okay. Well, how about if I start at the back and work forward then? We'll do that. That'll be something different. That's what we'll, oops. Well, that's ugly. There we go. All right. That's what we'll do. We'll start back there. I'm going to start with number 13. Is that okay with everybody? And then we'll go back to number 1. We'll just twist it up a little bit, make life exciting on this cold, wintry day. I guess this is about as winter as Atlanta gets. Okay. So for absolute value, what you want to do, because the absolute value of something is the positive. It's actually the distance between where a number is on a number line and how far you have to travel to get to the 0 on a number line. So whatever the result of the equation inside the two lines, inside the absolute value bars that I'm going to highlight here, or I'm going to try to highlight, whatever the value is there, whatever that is, it can be positive or negative, because when you take the absolute value of something, the answer is always positive. So then what you need to think about is every time you're working with an absolute value equation, you have to get the equation to the point where there's just some information inside those two bars. And then on the other side is a number, and then that would have to be the positive or negative part of that number. So this one, I don't have anything going on outside those bars. So then I'm going to set up my equation so that it's this answer right here is either plus or minus. It can be either one. Once you have nothing but the absolute value bars and something inside it. So now what I'm going to do is set up this so that it says m plus 8 equals 2, or m plus 8 equals negative 2. Because either answer, if I took the absolute value of positive 2, it's 2. But if I took the absolute value of negative 2, it's 2. So now I basically have two little algebra problems. So I'm going to subtract 8 from both sides. And I have m equals negative 6. I'm going to subtract 8 from both sides. And here I have m equals negative 10. So the answer to number 13 is m equals negative 6 or m equals negative 10.
Yay, I got that.
Yay! Good job. Is that Kennedy?
Yes, ma'am.
All right. Welcome. And so Are there any questions about that from Eli or Reese or Steven? Is anybody else here? Who else is here? No, Kennedy joined us.
Can you go over 19 when you get there?
Yes. Yes. I was gonna work. Yes, absolutely. We will definitely get there. And then because I write so big, I may have to erase some of the work, but I'll try and leave the answers up. Okay, guys?
Okay.
On number 14, we have the absolute value bars all by themselves. So now what we have to do is take the equation out of the absolute value bars, but our answer can be either positive 72 or it can be negative 72, because the absolute value of positive 72 is 72 and the absolute value of negative 72 is 72. So basically, once you take these two little bars out, you get two different equations. Is that making sense to everybody? Now we're going to divide both sides by 8 to isolate our variable. And we get r equals 9. And over here, we get r equals negative 9. So our two answers here are r equals 9 or r equals negative 9. Any questions about that? And did I erase too quickly? Everybody good? If we're good, I'm moving on. All right, number 15. Take everything out of those absolute value bars. And then we'll have two answers, either positive 13 or negative 13. So we've got negative 3k plus 8 equals 13, or negative 3k plus 8 equals negative 13. All right, so we'll solve this one. We're going to subtract 8 from both sides, and that leaves us negative 3k equals positive 5. Then we're going to divide both sides by negative 3. And so that gives us k equals 5/3. And over here,
Or
I'm sorry?
do you have to put the or?
No, you don't.
Okay. I just put a line and then put a positive on one side and a negative on the other.
That's fine, sweetheart. Thank you for asking. But yeah, that's absolutely fine. You don't have to write that. Just the fact that I have two answers, I'm happy. So negative 3k equals negative 21. Divide both sides by negative 3. And k equals 7. So the answers here are k equals 5/3 or k equals 7. How's everybody doing on these?
So when you do leave it in a fraction, you do reduce?
Like 2 5/3, like as small as it'll go? Or
because I just put I think it was 21, negative 21 over negative 3, but you do have to reduce that.
yes, if it can be, you want to take your fraction down to the smallest terms that you possibly can. And in this case, it was actually even. So that's even better. But even if you had, like, let's say that you had, let me think of one. I'm trying to, 25 over 10. You would want to reduce that to 5/2.
Okay.
So you definitely want to take your fraction to its smallest terms. So, so like if you got or even if you wanted this 5/3 to be a decimal, it would be 1.66667 or whatever. But yeah, you want to take it down to where it can't be reduced anymore. Great question. Number 16, you're going to have 2x plus 4 equals 4, or 2x plus 4 equals -4. Because once you take it out of the absolute value sign, you want that absolute value. You don't want anything to be on the outside of either one of those absolute value signs before you break down and do the 4 and -4. So you're going to subtract 4 from both sides. And so you're going to get 2x equals 0. So, and then you divide both sides by 2, and you'll get x equals 0. So x equals 0. And over here, you're going to subtract 4 from both sides. You get 2x equals -8. Hold on just a minute. I hate when that thing pops up and I can't get rid of it. Sorry about that. Divide both sides by 2, and x equals -4. So x equals 0 or x equals -4 for this one. All right. Number 17. Now this one, you'll notice that there is something outside the absolute value bars. So you've got to get it all by itself. All right. Before you can start changing that number on the right to its plus or minus value, you have to get it all by itself. And so in order to do that, there's multiplication going on. This -3 is being multiplied to whatever the result is of what would be inside that absolute value bar. So we're going to divide both sides by -3. That's how you begin this problem. So now we have k plus 5, or the absolute value of k plus 5 equals 7. So now we'll take the positive and negative value, because the absolute value bar is now all by itself on one side of the equation. And that's the goal before you start to take your plus or minus answer on the right. So we've got k plus 5 equals 7, or k plus 5 equals -7. We'll subtract 5 from this side to isolate our variable, and we get k equals 2. So for this one, k equals 2, or what do we get on this side? We're going to subtract 5 from both sides here, and that's k equals -12. How we doing?
Good.
Yay!
On both sides instead of divided.
I'm sorry, love?
I added the 3 on both sides instead of divided it.
Oh, okay. And I can see where that could be a little confusing because of the minus before it.
Yeah.
But in that particular case, you if this really were being, if that were the case, the problem would look like this. So you would have some sort of operation between the -3 and that. So if there's no operation in between the absolute value bar and the number, then it means it's being multiplied.
Okay, that's easier to remember.
Yeah.
Okay. So if there was a minus sign or something like that or anything, that's what would change that. But that I could see where that could be easily confusing. So you probably did the same thing on number 18, but notice there's no operation between the number and the absolute value, the first absolute value bar. So this means that on this one, number 18, you would be dividing both sides because that indicates that multiplication is going on. Because in algebra, whenever there is a number and then immediately like an open parentheses or an absolute value bar, or even later on down the road when you see a square root, it technically means something is being multiplied if there's no operation in the middle.
Okay,
That's
so number 20, you do subtract or you do add to both sides.
Yes, good job. Absolutely, you sure would. Good job, Kennedy. Good job.
Okay, that's easy to remember.
Okay, good. All right, so number 18, you're going to divide both sides by -6. Okay. And then now we've got the absolute value bar all by itself on this side because we've divided and got rid of that -6. So we've got the absolute value of -10 plus m equals, and then -42 divided by a -6 is a +7. So now we're going to set up our equation with our plus and minus answers and we're going to take away those absolute value bars by indicating that there's two possible answers. That's kind of what you're doing. When you take away those absolute value bars, you're opening up the possibilities of what could those answers be. Well, the answers could be positive or it could be negative because the absolute value of -7 is 7, or the absolute value of +7 is 7, and the absolute value of -7 is 7. So I'm going to add 10 to both sides. It looks weird because I'm going to cross that out so you guys know that's not the one I'm working on. And then I've got m equals 17 over on this one. So m equals 17. And over here, I'm going to add 10 here to both sides. And now I have m equals 3. So m equals 17 or m equals 3.
This is so much easier now.
Oh, good. I'm so glad to hear that, Mary Faith. Yeah.
I got to push up on number 19, but all the others are like making a lot more sense.
Okay, great.
On number 19, would you multiply by 4?
You absolutely would. Good job, Mary Faith. I'm going to erase this part so we can do that. I'm going to have you guys help walk me through number 19. My sweet little geniuses. So I think Mary Faith says we're going to multiply both sides by 4 so we can get those absolute value bars all by themselves. And she's absolutely correct. I think it was Mary Faith. That was you, right, baby?
Yes, ma'am.
Okay. So now we have 12 on this side, and over here we've got the absolute value of -10 plus 7r equals 12. Now, in order to take those absolute value bars out, we have to think of the two possibilities that it could be. It could be a +12 or it could be a -12. So now we're going to set up our two smaller algebra problems. We've got -10 plus 7r equals positive 12, or we've got negative 10 plus 7r equals negative 12. So we're going to add 10 to both sides. And that gives us 7r equals 22. And then we're going to divide both sides by 7, and r equals 22 over 7. Here's one, Kennedy, that you can't reduce. So r equals 22 over 7. I mean, you could reduce it, but it would be a decimal. I guess that's a better way to say that.
It would be an ugly decimal.
It would be an ugly decimal. You're absolutely correct. So I'm going to add 10 over here. And then that's going to give me a negative 2. 7r equals negative 2. Divide both sides by 7. So r equals negative 2/7. So r equals negative 2/7. Those are my answers for that one, for 19.
So even if you have a problem that's set up ready for you to solve, and you're about to like put it into the negative and positives, even if the number like behind the equal sign is a negative, you still turn it into a positive?
Yes, that's a very, very good question. I'm so proud of you for asking that. Yes, absolutely. You would, since it's already a negative, you would almost be thinking, oh, okay, well, it could be positive too. So no matter what happens, great question. Great question. It's always going to be two possibilities. You'll have the positive possibility and you'll have the negative possibility. Because it would be the opposite. I know that sounds weird, but that's really what it would be. Because if you're asking more than likely what's going to happen with regard to that, if that were the case in that particular one, there's probably going to be a negative sign outside of the front of the absolute value. And that's kind of confusing, but yeah. But you're always looking for both the possibilities. Good question. All right. On this one, I think somebody already said that you would add 3 to both sides, and that is absolutely correct. So now we have 8a. The absolute value of 8a minus 9 equals 23. And now we're going to take it outside of absolute value signs. Y'all are doing great. I'm so proud of you guys. And then we're going to set it up with its two possible answers. So you'll have 8a minus 9 equals 23, or 8a minus 9 equals negative 23. So we'll add 9 to both sides. And you'll get 8a equals 32. Divide both sides by 8. And you'll get a equals 4. So a equals 4. And then I'm going to do this one over here. 8a minus 9 equals negative 23. Add 9. And that's going to give me 14. Negative 14. Divide both sides by 8. And that's going to give me, here's one of those where, Kennedy, we have a fraction and we're going to just reduce it to its lowest terms. 2 goes into both of those. So I've got A equals negative 7 over 4. Not a pretty 7 there, but I reduced it. It was negative 14 over 8, and I could take 2 into both of them, so I reduced it to negative 7 over 4. How'd you guys do on those? And you can kind of see the answers there down below for the rest of the things, but I'm happy to go over any or all of them for Math Lab today. I've got another 30 minutes.
Did you
Ask
already
me
go over 11 and 12?
Yes, I can. Any other questions besides 11 and 12? You want me to go back to the beginning? I will definitely do 11 and 12. I'll go to those next.
Miss Sparks, can you do 10 after that?
Absolutely. I sure can. Oops.
Is there a quiz or a test tomorrow?
Quiz. Yeah. Won't be a test, just a quiz.
When is the final review due?
Monday. Monday. And what I'm probably going to do with regard to that is I'm going to check to see if you have it all done and check your work. But I will mark it complete, and you'll get that daily grade and that and the 5-point bonus. But I'm not going to take it away from you because that's what we're going to use in Math Lab both Tuesday and Thursday of next week. I will have Math Lab both days, but I do understand a lot of you are going to be spending your time studying for your history and language arts. I just wanted to be available if you wanted me on Tuesday, but I will definitely be available on Thursday. Okay. Number 11. All right. So number 11, you want to break this into 2 problems. So you've got this one, and then you've got this one. It's almost like a Venn diagram. So you've got, for that first one, we've got P plus 2 is less than or equal to 2P plus 6. So we're going to solve this one first. And I'm going to, because I like my variable on the left-hand side, because it makes it so much easier for graphing, I'm going to subtract 2P from this side, which then I have to do the same thing because I'm combining my like terms, but they're on opposite sides. So now I have negative P plus 2 is less than or equal to 6. And I'm going to subtract 2 from both sides. So now I've got negative P is less than or equal to 4. Now I'm going to divide both sides by negative 1 to get rid of my negative, which means I've got to flip my sign because I've divided by a negative. So now I've got P is greater than or equal to negative 4. I'm going to write that up here. P is greater than or equal to negative 4. And that's that part. And now for the other equation, I'll set it up. It'll be 2P plus 6 is less than negative 6P minus 10. So I'm going to add 6p to both sides because I like to have my variable on the left because it just makes graphing so much easier. So I've got 8p plus 6 is less than negative 10. I'm going to subtract 6 from both sides. That gives me 8p is less than negative 16. Divide both sides by 8. And now I have p is less than negative 2. So those are my two answers. And now for the graphing part.
It's an and, so you would face the line toward each other, right?
Yes. Because here's the results of what it is. It is an and because it's a combination. And so when I'm graphing, this p is greater than negative 4, or greater than or equal to. It'll be colored in because you do more writing when you write the greater than or equal to. So it's colored in. That extra line means to color it in right here. Color it in. And then it's less than. Okay, so it would go this. Oops, didn't mean to do that. So it's going to go this way, right? To be greater than would be going this way. But it's less than 2. So it's only that part. Because it's and. It has to be true for both. So it's there in the middle. So, all right, number 12. Once again, we have two different problems. This is one, and then this is one. That middle part, oh no, I lied. It's an or. My bad. Two different problems. Got this one.
I almost didn't see that.
I know. It's tricky, isn't it? Yeah. That or is real little. I'm sorry?
It's in such small font too.
I know. It's real little. Tricky. So for an or, this means it can be one way or another. So you won't have that combination thing. Okay, but we'll still solve them one at a time. We've got negative, whoops, trying to keep my colors consistent. I'm going to work on that first one. Got negative 6 minus 3p is greater than or equal to negative 6 plus 10. P. All right, so I want my p to be on the left-hand side. My variable sounds better. Negative 6 minus 13p is greater than or equal to negative 6. And so I'm going to add 6 to both sides. And I get negative 13p is greater than or equal to 0. Divide both sides by negative 13. And then p is, because I divided by a negative, I do have to flip my sign. So it's going to be less than or equal to 0. Okay? And then for my other problem, I'm going to, hang on, let me get this all erased. So I've got P is less than or equal to 0. Should have written that up at the top above that one. I think I'll do that before I start this next one. So P is less than or equal to 0. Sorry about my dog growling in the background. He sounds like such a ferocious beast, and really, he's not. So 6P minus 2 is less than 8P minus 4. Once again, I'm going to get my variable on the left-hand side. It's just so much easier for graphing. So now I have a negative 2P minus 2 is less than negative 4. I'm going to add 2 to both sides. So now I've got negative 2P is less than negative 2. And then I'm going to divide both sides by negative 2. And I've divided by a negative, so that means I need to flip my sign from less than to greater than, and I've got a positive 1. So P is greater than 1. For the graphing part, it can be one or the other, so we need to make sure both pieces are represented on our number line. So P is greater than 1. It's going to be open circle since it's only greater than. It's not greater than or equal to. And it's greater than 1, which means you can color it this direction. Like Miss Richardson said, you can always add like a little arrow there to kind of help you decide which way to color. And then P is less than or equal to 0. Because it's less than or equal to, it's more writing. Because you have that little equal sign, so it's more writing when you graph it too. So you're going to color it in. Once again, the little arrow tells you which way to color. So you color that way. So really the only part that isn't counted on this one is that part that's in between 0 and 1. P is less than or equal to 0. P is greater than 1. All right. And now number 10. How are you guys doing?
Good.
Yay. All right. So number 10.
After you do number 10, can you do number 6?
Yep. So number 10, sure can. Number 10 is this problem. 5 plus 4x is greater than or equal to negative 23. Or 7x plus 10 is less than 46. So we'll do the first one first. Keep my variable on the left-hand side. So minus 5 leaves me with 4x is greater than or equal to negative 28. Divide both sides by 4. And now I have x is greater than or equal to negative 7. For that side. Reese, are you still with us? Did she leave? 7x plus 10 is less than negative 46. So we're going to subtract 10 from both sides. And that's going to give me a negative 56. So I have 7x is less than negative 56. Divide both sides by 7. And I have x is less than negative 8. X is less than negative 8. So we're going to graph both of these. And because it's or, they will probably go in different directions. So we've got x is greater than or equal to negative 7, which means it will be colored in because there's more writing. Greater than or equal to. So we'll color that in. All right. And it goes in where it's greater than. So it's going in this direction. It's pointing this way. Or x is less than negative 8. And it's only less than, so it's an open circle. And it goes this way. So once again, much like that other one, there's not much that's not colored in. It's just between the negative 8 and negative 7. I believe the next one that was asked was number 6.
Yes, ma'am.
Okay, so I'm going to I can do one of two things here. I can divide by that 3 because I know that 123 is divisible by 3, or I can distribute. And I think most commonly y'all all are distributors. So I will distribute. I've got 3 times 8p plus 1 is greater than or equal to 123. Because here you have more of the flexibility to do that. As with the absolute value, you have no choice but to divide by what's on the outside. Subtract 3 from both sides. So I have 24p is greater than or equal to 120. I'm going to divide both sides by 24. And that should be p is greater than or equal to 5, because 24 goes into 125 times. So it's greater than or equal to that.
Okay, thank you.
Uh-huh. So there's the graph.
Can you also go over 2 and 3?
2 and 3, is that what you said? Kennedy, did you say 2 and 3?
Yes, ma'am.
Okay, I sure can. I just wanted to make sure I heard right.
Okay.
Absolutely. Whatever ones you ask. All right. On number 2, we're going to combine like terms because they're on the same side. We are just going to do the operation that's in the middle. It says 6n plus 7n. So that's going to be 13n is greater than or equal to 0. Divide both sides by 13. And we have n is greater than or equal to 0. And that's it. It's just a weird one because you're combining like terms on the same side instead of switching. And then number 3, we have like terms on the same side. Once again, we've got a negative n, which is really like a negative 1n plus 3n. So you find the difference and give the sign of the higher one. So that's 1 minus, and negative n plus 3n is going to be plus 2n is greater than or equal to 11. Subtract 1 from both sides. And now I've got 2n, it's hard to see, sorry about that, is greater than or equal to 10. Then you divide both sides by 2. And I've got n is greater than or equal to 5.
Okay, thank you.
Uh-huh.
Miss Sparks,
Definitely.
can you do number 8?
Number 8, I absolutely can. And the key thing on some of these, when you have the terms on the same side, is I think Kennedy, like that or was so little, or Mary Faith, we were talking about the font size. Sometimes it can get a little confusing on these because of the sheer font size. So be sure and kind of check on that, and watch your signs, watch your numbers, all that good stuff. Because the font on these tests, and that's true also of the SAT and ACT. Which one did you ask me? I'm so sorry, Eli. Was it number 8?
Yes, ma'am, number 8.
Okay. All right. So we have 2 problems here. And the first one is this. And the second one is this. So I'm going to do the first one up here. We've got 1 is less than or equal to n plus 8. So I'm going to subtract 8 from both sides. And I'm going to show you how I'm going to get my, how I like my variable on the left. What I'm going to do now, in order for me to read the graph, I need to flip I need to get my n over to the left-hand side. And in order to do that, I make sure, see how the fat side, the mouth side is open to the n? I want to make sure that happens again and make sure that my direction of my inequality is facing the same exact way, because -7 is the same as -7 is less than or equal to n is the same as n is greater than or equal to -7. I just feel like, even with regard to the hints that Miss Richardson gave last year with regard to graphing, it is so much easier to graph these when your variable is on the left. So now this is n plus 8 is less than or equal to 5. Subtract 8 from both sides. And I have n is less than or equal to -3. So I'm going to graph this now. And I have n is greater than or equal to -7. So once again, I've got more writing on this, so I'm going to color it in, -7. And it's greater than or equal to, but I also know it's got to be less than 3, less than or equal to 3. So it's going to be colored in the middle there. And I know that they write it like this.
Where did the x is less than -8 come from?
That's this problem down here. Number 10. The one that we did before. Sorry about that.
Oh, it's okay.
I can erase it if that's confusing. But I know that they write it like this. And you can absolutely do this. Oops.
Miss Sparks, are you going to send us a assignment sheet for all of our homework?
I can do that, but really the only thing I'm going to ask for, because y'all turned in the 2 big assignments last week as a quiz grade, the coloring things as a quiz grade. So you basically had these 2 review sheets, and then I think we did some classwork on Friday. So all I'm going to require is the 2 review sheets tomorrow, and that's it. Because I think that was almost everything, wasn't it? We probably did some inequality stuff in class from the textbook, did we? Right? But if you have these 2 review sheets done, I'll be good for the assignments on this. How's that? Is that a blessing or not a blessing?
A blessing.
Okay. But Eli, if you want to turn in everything you've got, that's awesome. That'll always be worth bonus on a daily grade for me. I know how hard you work. I'm really proud of you guys, and I appreciate everybody coming to Math Lab and working so hard. Are there any other questions on this worksheet or even the other worksheet?
No, ma'am. Thank you.
You're most welcome. I can roll up if y'all want to check the rest of your answers to make sure that you got them right.
Yes, please.
Yes, please.
There you go.
So do you have the answers for the first one?
Yes, sir. I do. Give me just a minute and let everybody check this, and then I'll put that back up too. And I can also post them on Google Classroom if you would like.
If that's better for you, you could post them on Google Classroom.
Either one is fine, and I don't mind doing it here. I just want to make sure, just everybody let me know. I can do it both places. Everybody let me know when you're done checking this, and then I'll pull up the other one.
Okay, I'm done.
Okay.
Thank you.
You're welcome. Everybody else done? Eli, did you get them all, honey?
Yes, ma'am. Thank you.
Bailey, you still with me? Did you get them? She's quiet. I don't know if that means she didn't get them. If she's good.
Yes.
Okay, good. And here's the answers to the other one. And then I'll post on, if it will help, I will also post them on Google Class.
Can you post them on Google Classroom, please?
I absolutely can. I will do that. I'll work on that now while y'all are checking them.
Thank you.
Okay, I have it posted on everybody's classroom. Now I know Bailey and Mary Faith weren't there on Friday, so I didn't know if y'all had any questions about these or you needed me to go over any of these.
No. The part 2 from today helped me learn the part 1.
Okay. Oh, great. Good job. If at any point today, you get stuck on something or the answers don't match up, just email me. Okay.
Okay, thank you.
You too, Bailey. If something happens where you get stuck on something, just email me. All right.
Okay, thank you.
All right. If there's not anything else, I'll post an assignment sheet, but really all that's gonna be on it's gonna be the 2 review worksheets, and that's it. If you all turn that in tomorrow, that will be good for a daily grade for this semester. Or I mean this chapter. Lord help us. I'm ready for Christmas break. Can y'all tell?
Thank you.
You're welcome. Y'all have a blessed afternoon.
You too.
Bye-bye.
Thank you.